Hello and welcome. In today's video we're going to continue our discussion on graphing quadratics, but now we're going to look at adding a number or a constant after our ax squared term. First we'll recall how to graph just ax squared, or a parabola that's being multiplied. In our previous video we said that unless there's addition or subtraction, our vertex is going to be at 0, 0. So here I've got 4x squared, I don't see any adding or subtracting, which means my vertex will stay at the origin, 0, 0. And then from there, I ignore any adding, subtracting, multiplying, or dividing, and I boil this function down to just y equals x squared. When I do that, I can derive my pattern. Going left 1, we can think of it as a negative 1, and then when I square that negative 1, I get a positive 1. Positive means up, 1. Left 2 we can think of as a negative 2, and when I square it, I get positive 4, so positive means up, 4. Left 3 would be a negative 3, and when I square, I get positive 9, and then we move on to the right. Right 1 squared is positive 1 squared, which is positive 1. Right 2 is positive 2 squared, which is positive 4, and then lastly, right 3 would give us up 9. So here is my pattern. But then we go back and we decide, was there any multiplication or division that is going to change our pattern? And there was. If I look at my original function, there's a 4 in front. So I'm going to take my x squared and multiply it by 4. So up 1 becomes up 4. Up 4 becomes up 16. Up 9 becomes up 36. Up 1 becomes up 4. Up 4 becomes up 16, and up 9 becomes up 36. And this is the pattern that we're following. Left 1 up 4, left 2 up 16 is off my graph, and so is left 3 up 36. Right 1 up 4, and then 16 and 36 are off the graph. So my graph will look more or less like this. In our second one, I don't see any addition or subtraction, which means my vertex is still at the origin, 0, 0. I ignore any adding, subtracting, multiplying, or dividing in my function, and I boil it down to its most basic form, which would just be x squared. And from here, I develop my pattern. Left 1, up 1. Left 2, up 4. Left 3, up 9. And then on the right, right 1, up 1, right 2, up 4, right 3, up 9. We go back and we look to see if there was any multiplication or division, and there was. We are multiplying all of our x squareds by negative 3. So my entire up column I'm going to multiply by negative 3. The negatives make the up becomes down, so this becomes down, and 1 times 3 is 3. Negative makes my up go down, and 4 times 3 is 12. My up becomes down, and 9 times 3 is 27. Negative means down, 1 times 3 is 3. This would be down 12, and then down 27. And this is the new pattern I follow. So left 1 down 3, left 2 down 12, which is a little off my graph, right 1 down 3, right 2 down 12, and then we connect our dots, and we have our parabola. We're going to go ahead and explore what addition or subtraction is going to do to the graph of your function. In order to do this, we'll first create a table, and then we'll compare it to our standard x squared graph. When I plug in a negative 3 to my g of x function, I've got negative 3 squared minus 2, which ends up being 9 minus 2, which is 7. Negative 2 squared minus 2 is 4 minus 2, which is 2. Negative 1 squared minus 2 is positive 1 minus 2, which is negative 1. 0 squared minus 2 is 0 minus 2, which is negative 2. 1 squared minus 2 is 1 minus 2, which is negative 1. 2 squared minus 2 is 4 minus 2, which is 2. And then 3 squared minus 2 is 9 minus 2, which is 7. So when I plot these points, I've got the point negative 3, 7. I've got negative 2, 2. -1, -1, 0, -2, 1, -1, 2, 2, and 3, 7. So I connect my dots and my graph looks something like this. Now my pattern, if I start at the vertex, is left 1, up 1, left 2, up 4, left 3, up 9, and then back to my vertex on the right, right 1, up 1, right 2, up 4, and right 3, up 9. This is the same pattern that we used when we were graphing just x squared. If we take our left and rights and we square them, we get this up column. So the pattern isn't changing, but what is changing is our vertex. This point right here has different coordinates than it did before. It used to be 0, 0, but now it's 0, -2. So my vertex changed when we introduced that subtraction. So our pattern is not affected by addition or subtraction, but the vertex is. So in our next page, I see that there's no multiplication or division, so my pattern will not be changing, but I do see some subtraction after the x squared. This is going to change my vertex. We're going to move the whole graph down 5 units. So instead of being here at the origin, we're going to drop our graph down 5 units, 1, 2, 3, 4, 5, and this is our new vertex. So the vertex then has the coordinates 0, -5. And then from there, I create my pattern. Ignoring any adding, subtracting, multiplying, or dividing, this boils down to just x squared. So my y equals x squared. I'm going to go left 1, when I square it, up 1, left 2, up 4, left 3, up 9, right 1, up 1, right 2, up 4, right 3, up 9, and then we follow our pattern from the vertex. So left 1, up 1, back to the vertex, left 2, up 4, back to the vertex, left 3, up 9, back to the vertex, right 1, up 1, back to the vertex, right 2, up 4, back to the vertex, right 3, up 9, and then I have all my dots, so I go ahead and connect them best I can, and this is the graph of our parabola. So addition or subtraction does not change your pattern, it only changes where the vertex is. So in my second one, I see a +3 out here. That +3 is going to move my vertex. It's going to move everything up 3. So I start at the origin. Normally we're at 0, 0, but we're adding 3. So my graph is going to be centered around a vertex of 0, 3. So my vertex has the coordinates 0, 3. And then from there, my pattern is not changing. With my x squared, there's no multiplication or division. So my pattern is just going to stay exactly as it was before. Left 1, up 1, left 2, up 4, left 3, up 9, right 1, up 1, right 2, up 4, right 3, up 9. We follow the pattern from the vertex. Left 1, up 1, back to the vertex. Left 2, up 4, back to the vertex. Left 3, up 9 is a little off my graph. Back to the vertex. Right 1, up 1, right 2, up 4, and right 3, up 9 would be maybe right about there. Connect the dots best we can, and there's the graph of your parabola. We did not change the pattern because there's no multiplication or division. The only thing that changed is where the vertex is. In our next example, I do see that we're shifting everything up 4 units. So from my center, normally we're at the origin, I'm going up 1, 2, 3, 4. So this is my new vertex at the coordinate 0, positive 4. So my vertex is at 0, 4. I then ignore any adding, subtracting, multiplying, and dividing, and this boils down to just x squared. So my pattern, left 1, and then I square it, up 1. Left 2 squared is up 4. Left 3 squared gives me up 9. Right 1 squared is up 1. Right 2 is up 4. And right 3 is up 9. I look back to my original function and I do see that there's a negative in front of my x squared, which means we're multiplying everything by a negative 1. Remember, all a negative does when I multiply is it makes our ups become down. So this means down 1. Down 4, down 9, down 1, down 4, and down 9. And then we are just following the new pattern. Starting at the vertex, left 1, down 1. Back to the vertex, left 2, down 4. Back to the vertex, left 3, down 9. Back to the vertex, right 1, down 1. Back to the vertex, right 2, down 4, back, and then right 3, down 9. Connect the dots the best we can, and this is the graph of our parabola. In our next example, I do see addition and subtraction. Subtraction at the end means we're going to move our whole graph down 6 units. So instead of starting at the middle, I start down 1, 2, 3, 4, 5, 6, and here's my new vertex. So that point is 0, negative 6. This is where everything's going to be centered around, and then I create my pattern. My pattern comes from y equals x squared, left 1, up 1, left 2, up 4, left 3, up 9, right 1, up 1, right 2, up 4, and then right 3, up 9. Any multiplication or division changes our pattern. So I do see that we're multiplying everything by 2, which means this is going to become up 2, up 8, up 18, up 2, up 8, and up 18. We now follow that pattern from the vertex, starting at the vertex, left 1, up 2, back to the vertex, left 2, up 8, back to the vertex, left 3, up 18 would be a little off my graph, back to the vertex, right 1, up 2, back, right 2, up 8, back, right 3, up 18, which is a little off my graph, and then we connect the dots the best we can. And there's the graph of your parabola. Go ahead and take a moment, pause the video, and try these next two on your own. We are moving up 9, so our vertex is at the point 0, 9. My pattern, left 1, up 1, left 2, up 4, left 3, up 9. And then right 1, up 1, right 2, up 4, right 3, up 9. It is going to be changing because we are multiplying by a negative 3. So when I multiply by negative 3, all the ups become downs. 1 times 3 is 3. Up becomes down. 4 times 3 is 12. Up becomes down. 9 times 3 is 27. Up becomes down. 1 times 3 is 3. Down 12 and down 27. So from my vertex, I go left 1, down 3, back to the vertex, left 2, down 12, back to the vertex, left 3, down 27 is pretty far off my graph. Back to the vertex, right 1, down 3, back, right 2, down 12, back, right 3, down 27, which is pretty far off. So I just connect the dots I have, and more or less this is the graph of my parabola. My last one is getting shifted down 8, so my vertex is at the point 0, negative 8. And then my pattern, I start with my normal pattern, and then we are going to multiply because there is multiplication in my expression. There's a coefficient of 4 in front of my x squared, so I'm going to go through and multiply everything by 4. So I end up with up 4, up 16, up 36, up 4, up 16, and up 36. And again, we are multiplying our pattern by 4 because we are multiplying x squared by 4 in our original equation. So left 1 up 4, back to the vertex, left 2 up 16, back to the vertex, right 1 up 4, back to the vertex, right 2 up 16. I ignored our 36s because they're just a little too big to fit on our graph. We connect our dots, and there we go. All right, that brings us to the end of our video. Thanks so much for watching, and have a great rest of your day.